today we're going to solve another problem. Yesterday we already solved the right distribution property for vectors, which states that if we have two vectors A and B, and then write multiplication by vector C, I forgot to turn on the timer. Nice, now it's better. Then it is essentially equivalent to A right multiplication C plus B right multiplication C. So this is right distribution. In fact, the left distribution properties also takes place here. And it says that left distribution is A cross product B plus C is essentially AB plus AC. So that's pretty much it. And this can be proved in the same way as we proved the right distribution property, so I'm not going to stop here. But what I would like to prove here in this video is that pretty famous theorem, which is the sine theorem of simple planimetry, wherein when we have a triangle ABC, let's say we have a triangle ABC, and we have three angles. We have angle alpha, beta, and gamma. And so what this theorem states is that basically the ratio of different, of the sides of the triangle, by the sines of the opposite angles, they are equal. So let me just demonstrate that. It says that if we have the side A, which is the opposite to the point A, the side B, which is the opposite to point B, and C, which is the opposite to point C, then we have A over sine alpha equals to B over sine beta, C over sine gamma. So that's basically it. So these ratios are equal. So we need to prove this. And in fact, we can use the fact of our right distribution property and the property of, vectors in a triangle to prove that. So let's designate these vectors the following way. Let's say that BC, vector BC is the vector A, and let's just depict this on the picture like that. And then vector CA, let it be CA be vector B, right? And then another vector AB would be equal to vector C. Vector C. All right, that makes sense. So what kind of property we can derive from here? We can see that if we, for example, if we try to sum A plus C, we can see that that would be minus B. Consequently, that A plus B plus C would be equal to 0 vector, which is very interesting, and we can use that fact that it equals to 0 vector, because now we can just take, let's say A, and try to find the cross product with its sum. A plus B plus C should be equal to 0 apparently, because this is the 0 vector, and multiplication of 0 vector by any vector would give you the 0 vector. But it is interesting because we have A and A, we can apply the left distribution property. In fact, we could have applied the right distribution property here. But I use left distribution property because this is something that most people are used to working with. So I'm going to use A and B in here, and then A plus cross product with C, which equals to 0 vector. And we have to keep in mind that this is actually the vector, which is a 0 vector. I just add the arrows above them because, just for being more explicit. So what do we have here? In fact, that vector multiplied by itself, it goes to 0, and then we only have a pretty simple equation AB equals minus AC, which is equivalent to saying AB equals CA, because, this is the definition of what cross product is, right? So, I mean, it is kind of anti-commutative. If we change the places, we change the sign. And then, that's quite interesting. That means that our magnitude of this a, b, and sine, what is that? Sine, sine. The degree between them is a and b is gamma in this case. Well, it's kind of b minus gamma, but this is the same as gamma, right? And then we have c and a. Yeah, it should be the same thing. And then we have CA, and, well, the angle between them again. This is the sine of beta. P, in fact, P minus beta. P minus beta. And so what do we have? We have A, B, C, A. Okay, we can get rid of A on both sides. And we can simplify that. It's basically B over C, which equals sine beta over sine gamma, which is equivalent to B over sine beta equals to C over sine gamma. And in the same way, we can prove that if we, for example, multiply B by cross product A plus B plus C, zero vector, we can see that B cross product A equals to B or C cross product B, C cross product B. And we can find the same relation for B and, in this case, A and C. So A over sine alpha is equals to C over sine gamma. And from this we can conclude that A over sine alpha, so second number, second step, equals to B over sine beta, which equals to C over sine gamma. So that's pretty much it. That's all the proof that we need here. Pretty simple one, pretty simple problem.